Good afternoon, everyone. Please confirm if you can hear me in the chat and you can see my screen. Good afternoon, good afternoon, good afternoon. If you can hear me clearly and you can see my screen, let me see your yes in the chat. Good afternoon, Ridwan. Thank you so much, Merit. Good afternoon. Welcome, Aziz. Good afternoon. Good afternoon, Samuel. Good afternoon, Khalil. Good afternoon, Jamilu. Good afternoon, Basi. Good afternoon, Kadir. Good afternoon. Good afternoon, everyone. Welcome to the free AI in every city 2025 Python for data science and machine learning track. Yes, so we are rounding up with the beginners level track today. We started with the data analytics with Power BI. We call it data storytelling and visualization. And today we're going to be taking the second learning track of our beginners track for this year, which is the Python for data science and machine learning. How was our learning? How was our learning? How has been our learning since Monday? Let me see your, I want to hear yours. Let me see your feedback in the chat. Let me see your feedback in the chat. How has it been since day one? If you've learned anything at all, share it in the chat. Share it in the chat. Let's hear us. Let's hear. I want to hear everybody. Aisha said it was awesome, fantastic, fantastic. Victor said it has been amazing. Thank you so much for those feedback. So today we are going to be doing more like what we call a recap, and we have our facilitator who is going to be taking this session. Our facilitator who is going to be taking this session and is here for us. It's someone who you are actually familiar with. So it's going to be running us through what we've been learning since I mean for the last 5 days, what we've been learning. So before we move on to the session proper, let me quickly introduce us to DSN. I mean, we're all familiar with DSN. So this is our agenda for today. I'm going to be sharing a few things about data science in Nigeria, and then I'm going to be telling us about the journey to the boot camp. And yeah, we are going to move on into the session proper, and we are going to be having questions and answer. We'll take a few questions before we call it a day, and then we'll take a photo shoot, and that'll be all for today. So quickly, let me run us through what we do at DSN. We have a commitment to raise 1 million AI talent and build solutions that improve the quality of life and well-being of 2 billion people in the emerging market. We have 5 areas of focus. Yeah, if you know DSN, you will know that this is what we do at DSA. We are very heavy on community development. We do a lot of research, and we do what we call capacity building. We equip others. And talk of ecosystem development. We've realized that it's not good to go alone. I mean, it's better when you go together with everyone rather than you just moving alone. So we develop the ecosystem, and then we do what we call consulting and product development for top firms. This is our annual report for last year. I'm going to be leaving the screen for a few minutes for you to scan through to get to know what we do at DSN. So this is when you scan through this link, you get to see the detailed things that we do at DSN. Yes, so like I told you that we're very heavy about community. So we call it community development. Community is like the core of data science Nigeria. We have our presence in all the states in the country. Yeah, I mean all the 36 states that we have in the country, we have our presence there. And we've even expanded outside of the country. We are now in over 14 countries, and our learning reach, we have a learning reach of over 1 million people. But when we're talking about learning reach in terms of country, we have learning reach in over 96 countries. Yes, so we're that big. And this is the segment in the community. This is how we've been able to categorize everybody into the community. This is how we've been able to deliver values for everybody in the community. We have our campus community, we have our AI for schools, we have our AI researchers, we have our kids and teens community, we have our AI startups. So everybody belongs to a particular segment in the community. We have the DSN ladies in AI community. This is a dedicated community for the females. Yeah, so if you are a female on this call, I will advise you to join I will advise you to scan this link and join the community group. There are a lot of exciting things that they are doing in the community currently. And moving straight to why be a DSNer. Why should you be a DSNer? Because for us to know that you are our committee member, you need to associate with us, and there's a need for you to get your membership ID. And those are the following things that we have for, I mean, to convince you why you should be a real DSNer, because it's not only about participating, it's also about being an active community member. So we have what we call access to mentorship opportunities, which we share with our community member. Um, all through the month, I mean through the year, since January now, we've been running what we call mentorship classes for our community members. And then we also expose our community members to what we call premium training. And one of it is why we're here today now to learn the core of Python for machine learning and data science. We expose our community member to premium training, premium content, and resources for them to upskill themselves. And we also enable our community members to participate in research. Yeah, we enable them to participate in research. We aid them with learning that will help them to build solutions from ideas. So we call it from ideation to building products that are tangible. And at the end of the whole day, I mean, at the end of the year, all our active committee members get a certificate of participation, which will signify, I mean, which will confirm that you are actually an active committee member. So this is QR code for you to scan to become a DSM member. So if you are here to get your DSM membership ID, this is the right time to scan this QR code so that you can fill it, and you also can get your AI membership ID. And then this is another QR code for you to scan to get to know the community that is very close to you. Like I said the other time, we have our presence in over 30 states. I mean, I'm even saying over, we have our presence in 30 states of the country, and we've also expanded out of the country. So once you scan this code, you are going to see a community nearby you, either a campus club or a city community that is close to where you are staying. And how we be able to make sure that we equip our community members? We have what we call the annual learning calendar. This is a structured learning calendar for our community members. You will see that we are currently in May, and if you can see my number 3 here, what we call the AI Bootcamp free AI classes, and that is what we are currently doing. This is the calendar that we've been following strictly since January, and we are here in May, currently doing the free AI classes. So next month, you can see all the other activities that we have, and this is what we are going to be using through the year. So I will advise you to do a quick screenshot so that you can also follow. I mean, you can be following us as we're also ticking all of these activities as we go through the year. So this is even the QR code you can also scan to have access to the annual learning calendar. Yes, so this is DSN Knowledge Box 4.0. This is what I call the brain box. I call it the brain box. This is a knowledge board that it's actually an hard drive. I mean, it's a repository that houses over 25,000 learning content. Yes, I repeat, over 25,000 learning content. Talk of anything you want to learn on data analytics, data science, data engineering, and artificial intelligence. You are going to see it in this repository. You are going to see it in this repository. And this is the 4.0, which means that we've actually updated the knowledge box 4 times. And that's why we name it the DSN Knowledge Box 4.0. So, journey to the bootcamp, journey to the bootcamp, journey to the bootcamp. By now, you will probably have been hearing few things about bootcamp. Okay, what is bootcamp? What do they mean by bootcamp? Bootcamp is the what I call the biggest event that we run in the community. In the year, I mean, it's an annual program that we do at DSN, and the journey starts from the free eye classes which we are currently doing. And that's why it's very important that if you want to participate in bootcamp, then you need to start from the free eye classes in every city. The AI bootcamp is an all expense paid program that we do. Yeah, every year where we bring in the best of the best. I mean, the best of the best talent. We accommodate them, and we feed them, and we don't feed them only with food, we also feed them with knowledge. Yeah, for 5 days it's an immersive experience which you don't want to miss. I'm going to be sharing some pictures later, so you are going to see how big boot camp is, and this is the journey to the boot camp. This is how it looks like. After this Friday class in every city, we are going to be having the hackathon, and after hackathon we are going to be having a validation quiz assessment, and we are going to move to the boot camp qualification hackathon, the final selection, the announcement of the winners, and then the AI bootcamp, they get to attend the AI bootcamp. So this is free class in every city. The free class in every city is not just starting this year. Yeah, I need to emphasize that. These are pictures from previous years. You can see pictures from previous years of free classes, which used to be physical. But this year, we are going the route of making it hybrid. We are going to be having the virtual live sessions, and later on, we are going to be having the physical meetup, which will be holding across the country. And these are pictures from the boot camp itself. So you can see this is the boot camp that we had last year um, at the University of Lagos, Lagos, Nigeria, where we brought over 200 people to attend the boot camp. The journey started from the free hire classes with 30,000 learners. And we selected the best of the best. 200 of them were housed physically in Lagos to enjoy what we prepared for them, the boot camp. These are more pictures. These are more pictures. These are more pictures. These are picture highlights from boot camp. It's a very big event which you don't want to miss. We have a lot of activities created. Talk of practical learning. Talk of theoretical learning. Talk of lifestyle. Talk of award and recognition. It's a full-blown event. It's a full-blown event, and I want to believe that you don't also want to miss it this year. Yeah, so these are pictures. These are more pictures from the DSN here at Bootcamp. So yeah, those are more pictures. So we also have what we call the poster session where our committee members showcase their prowess through their poster presentations. They tell us what are the emerging research things. So I mean they present you if you've been hearing about conferences, talk of DLI, talk of ICLR, talk of Africa NLP, yeah, so you know it's carried the same weight. So our committee members send in their paper, we verify it. I mean, we vet it, and if it's a good one, we call them to come and present it at the AI Bootcamp. Yes, so this is how we've been running the prayer classes this year. You can see we started last week actually, 5th of May with data storytelling and visualization, and we are here today, this week, for the Python for data science and machine learning. So next week is going to be another learning track for intermediate now. The data storytelling and visualization and the Python for data science and machine learning and naturally for the beginner's track. So now, starting from next week, you can also key into this as an intermediate learner. We are going to be exposing everybody to what we call the core, the fundamentals of prompt engineering. Yeah, so this is an AI related topic which I want to believe you would like to also participating. Yeah. And in the fourth week, we are going to be having end-to-end data analysis with Microsoft Fabrics. So this is a topic that I will say it for the advanced because if you know about Microsoft Fabrics, you will know that Microsoft Fabrics is everything you need to learn. Everything you need to learn in the sense that Microsoft Fabric houses, or let me say Microsoft Fabric caters for data engineers, data science, and data analytics at the same time. So yeah, so all you need to do is just to follow us through. I mean, let us take you by the hand. Let's take you through this journey of these free classes, and by the end of the I mean next, so that will be in the next 2 weeks. You should be able to also do few things with Microsoft Fabrics, and we'll move into the hackathon and project participation in June. Yeah, so how we're bringing our facilitator here now. It's time to bring our facilitator in, who is going to be doing justice to what we've been learning for the past few days. I mean, since Monday, it has been an awesome learning experience. So I'm going to be bringing my good friend, Airways, who is going to be showcasing us. I mean, it's going to be explaining to us what exactly is Python and then how can we use it for machine learning. Just a minute while I bring Airways.
Strategic train the trainers approach ensured that even participants in remotest locations could gain access to cutting edge knowledge necessary for certification and future success. In collaboration with the International Trade Center (ITC), the program extends its reach to empower micro, small, and medium enterprises in the agribusiness sector. Recognizing the pivotal role of educators in shaping the future workforce, the partnership extends its training efforts to primary, secondary, and tertiary institutions, equipping teachers with AI-driven learning experiences. In the collaborative efforts between Microsoft and Data Science Nigeria lies a shared vision of building a better society, one where digital skill is not just a privilege, but a fundamental right, accessible to everyone, everywhere.
You're welcome to Data Science Nigeria Artificial Intelligence Bootcamp 2024.
Apologies for the technical glitches. Please confirm you can hear me clearly. If you can hear me clearly, let me see your yes in the chat. Thank you so much, Mitchell. Thank you so much, Kadio. Thank you so much, team. Thank you so much, everyone. Apologies for the technical glitches. So I'm going to be bringing Hayways, who is going to be facilitating this session. I'm going to be bringing him right away. And yeah, if you are, I mean, if you've been part of this community for a while now, even if you joined last year, you will actually know who Hayways is. Ewezu was the facilitator for last year. It took us for the 5 days. I mean, it took us for actually part of the 5 days. And he's also here today now to walk us through what we've been learning from day one, which is Monday till today. So I'm going to be bringing Ewezu now. If you're excited to hear from Ewezu again, let me see your yes in the chat. Let me see your favorite emoji in the chat. Let me see your favorite emoji in the chat if you're excited. Team is saying yes. Team is saying yes. Let me see your favorite emoji. Praise is dropping fire emoji. Enoch is clapping already. Thank you so much, everyone. So I think we're all ready for Ewezu now. Hi, Ewezu, please confirm you can hear me and you are ready for us.
Yeah, I can hear you and I'm ready.
Thank you. Over to you.
All right, so good afternoon, everyone. I hope you're all doing well. It has been a while, and I hope you've had fun this week. Yeah, so because I know that you guys have like sort of like gone through some material on AI and ML over this past week. I won't dwell too much on that. I'll just do a brief overview and then we might do a hands-on session if time allows. All right, so it's nice to meet you guys again. So let me share my screen. Yeah. Share my screen. All right, so can you guys see my screen? Please type in the chats if you can see my screen. All right, nice, good. So and guys is now, but I'm sure there might be some new members there. So I would like everyone to tell me their own definition of AI. What do you think artificial intelligence is? So you guys should please participate. Let's make this as level as possible. I'd like to hear all your interesting definitions of AI. Can I go full screen? All right, so who knows what AI is? Who's willing to tell me what they think AI is? Come on now, guys. Be fun. Let's contribute. All right, good. So Praise said it's a branch of technology that deals with yes, that's very correct. That's very nice. That's very good. Who else? Who else? Who else? Who else? Who else? Clone humans and machines. That's close enough and fun. It's not bad. It's a nice attempt. That's nice. So anyone else, at least like five, at least seven guys should respond. At least seven. Yes, simulate, not stimulate. Yes, simulate human behavior using ML and deep learning. Yes, building intelligent machines. Yes, that's also very close. Yes, yes, okay. So yeah, that's good. I'm happy with what I've seen thus far. Yeah, so AI is the word that people use a lot, really. They really understand what it means. They just use the word to either market their products or make themselves sound very intellectual, But as we all know, AI is basically man's attempt to get machines to attain human level intelligence or more, really. That's pretty much what AI is. You try to simulate human behavior or thinking and use that to solve different kinds of problems. And as we all know, we have different fields in AI. There's machine learning, the deep learning, which we all from, and there's also reinforcement learning, which works a bit differently than these two techniques. So like ML, which is like very statistical based, and deep learning, in which you build neural networks. Reinforcement learning involves you having an agent that interacts in some computer simulated environment, and that agent learns how to perform a task by being penalized or being rewarded by what we call a reward, essentially. So when it does things that are beneficial, it gets rewarded. When it does things that are bad, it gets penalized. And through those two mechanisms, you learn how to perform that objective. So that's also, by the way, for those who want to be aware of what reinforcement learning is, so that's that. And typically, as we all know, like AI requires vast volumes of data. We need large data sets, very large data sets, which often have to be labeled. But although there are also ML problems that can be solved using unlabeled data, like for example, customer segmentation, in which you perhaps try to segment your customers based on their behaviors like how they spend and characteristics like their income level. So you try to those kinds of things where you are trying to group. You could use unsupervised learning techniques that don't require label data, as well. Yeah. So machine learning, as I said, makes use of statistical models, statistical techniques really to get computers to perform tasks without human interaction. So we're basically using statistical models and algorithms to help computers do tasks that humans normally can do. This could range from classification to regression, essentially, yeah. So it could be classifying someone's gender based on the physical characteristics that it could be classifying a person's likelihood to pay or default on a loan. It could be predicting someone's score in an exam, given how many hours they put into studying, how often they attend classes and whatnot, So there are so many problems that can be solved by machine learning. So many. Yeah. And also, as we all know, it's a field that lies at the intersection of many fields. So statistics, biology, engineering, signal processing, databases, accounts, visualization, ML has a link with every single one of them. And it's why you often see MLB is sort of melting pot for different people in STEM. People from engineering backgrounds find them in ML, who do study computer science, find them in ML. People who need statistics or math, they find them in ML, So it's a melting pot for different scientific disciplines, you know. And that's partially due to how this technology is being leveraged to solve problems in different facets of life. So naturally, you need people from those different domains to contribute into making this technology very useful, in the respective domains, yeah. So these are certain things that you can use them all to do to detect spam. That's a classification problem. To detect credit card fraud, that's under anomaly detection. And who can tell me what kind of approach you use for credit card fraud detection? Usually the supervised approach or not supervised approach, or can you use both? I would like to know what you guys think. You can use it for collaborative filtering. An example of that is recommending products to someone, to diagnose patients for face detection, etc., 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 etc. You know, yeah. And just to whet you guys' appetites, if we have enough time, the project we embark on today is going to involve it's going to be a calculation problem as well, but it's going to involve a natural language processing. I hope does anyone know what that means? If you do, just type what you think it is in the chat. Yeah, so yeah, moving on. So usually when we want to build our models, you have to like sort of understand exactly what problem you're trying to solve. The problem you're trying to solve is going to inform what data you're going to use. And you're going to source for different data sets. You have to find the most appropriate ones. You have to understand exactly what's in your data set. You have to know what's in it. So actually know if it's usable. All right. Yeah, and then you have to prepare your data. Like, I mean, for example, let's say in our example today, which we're going to go on to, you want your model to be able to understand human text. Like, machines not they don't understand human language that way. They understand numbers. So you're going to have to convert those alphabets into numbers, a more stable form that they can understand, which are actually called tokens, yeah. So that's an example of how you can prepare your data. Another thing could be you searching, okay, are there entries that are missing? Are you deciding how you want to fill those missing entries, and whatnot. Another thing could be if you want to embark on regression and your features, let's say you have lots of numerical features, and let's say one numerical feature, like they are very, very large numbers. Because of how large those features are, your model could probably give like a bigger weight to that particular feature. So to avoid that, you standardize. So these are different things that you have to keep in mind and do when you want to deploy machine learning to solve any problem that you choose to solve. Yeah, and after we prepare it and do some EDA, we model, we evaluate performance. You could use metrics like accuracy, F1 score. You could use models like naive Bayes. You could use pre-trained models as well if you are trying to do it like natural language understanding or natural language processing. So there's so many things that come into play, but this is the basic framework. Know what you want to do, understand your data, prepare your data, do some EDA, create your model, train it, evaluate on your test sets, deploy, you know, and it's a very iterative process because I mean most of the time, lot of the time, if your first model might not be that good, so then you evaluate, you tune hyperparameters to try to squeeze out better performance, until you get something that's more tenable, and the likes, yeah. So I think I saw described these two SWOT and unsupervised earlier. But just to go through them again, I mean, supervised learning is basically capture and regression. And your data sets, you have a target variable. The target variable is numerical in case of regression. And in terms of classification, it's like it's a class. It's a class is just and to represent these classes, we use discrete numbers. So we use number 0, 1, 2, 3 to represent different classes. So that's basically like the lowdown for supervised learning. We have a target variable that's either numerical or categorical. And then for unsupervised learning, we just cluster. I think I mentioned that earlier as well. And lastly, I think our practical workflow was an unsupervised learning problem where we do customer segmentation. So here you want your data, you want your model to find patterns in the data and then group different samples based on whatever patterns your model has seen. And I'm giving customer segmentation as an example of that as well. And then there's a third one, which is called semi-supervised learning. And, as you all know, in the past year and some months, LLMs have gained traction. They become very popular. They become a very big part of our digital activities. And, that these things are trained on large amounts of data, like massive amounts of data. Labeling every single one of those samples is either very expensive because to get the domain experts, let's say you want your LLM to be very good at health, to get doctors to sit down and label your data, like you have to pay them a whole lot of money because they're experts. It also takes time. So self-supervised learning was a technique that was sort of born out of necessity in the sense that we want to be able to save time and save cost on labeling our data sets. To self-supervised learning, what actually happens is that the model itself sort of generates those labels by itself. And how it does that is a long story and, quite complicated, but that's what they just. The model looks for signals in your data set and then use those signals to guide it in quote unquote labeling. It doesn't actually label, but just quote unquote labeling the data set for it to make predictions and stuff. So that's basically how it is. Yeah, and we have descriptive and predictive and prescriptive analytics. And they all answer different questions. What has happened, what could happen, and what should we do to make it happen or not happen? And I mean, ML is usually like predictive. We want to make predictions. We want to know the price of the car. We want to know the population of the country. We want to know someone's income level based on certain criteria, and stuff like that. So, you know. And the thing is that when you don't have these predictions, Like there are times when you want to be able to influence outcomes. You don't just want to be able to have possible, but you want to be able to influence them. And that's where prescriptive analytics comes in, when you look at what you can do to make something happen or to make something not happen and stuff. So that's pretty much the lowdown. And when writing your scripts, I think we all know that the scripting language for ML is mainly Python. And you can write your Python code in your VS Code, Anaconda, Jupyter Notebook, or Google Collaboratory. For those of us who do deep learning, I'm sure we all love our Google Collaboratory or perhaps Kaggle as well because of the free GPUs that they give us. Because of the free GPUs that they give us. Because I mean, when training deep neural networks, without GPUs, it could take forever. It could spend forever to train. Actually, in fact, just before this course, I began to train our model ahead of time because I knew it to take a long time for it to run, despite me using GPUs as well. So yeah. Let's see what else there is that I'd like to cover for you guys. Um, yeah, so one thing that's very important as someone who wants to get good at machine learning is to always try to tackle different problem sets and try to experiment. And you need data to experiment. You need data for this. And these are places where you can get your data from. You can get your data from Kaggle. You can get your data from the UCI ML repository. That's a very popular one I use a lot. You can get data. You can get mixed data. I think mixed data is basically handwritten images. If you're into computer vision, ImageNet, there are so many places where you can get data, but these are just a few places where you can get data, for when you want to practice in your spare time. Yeah, so I believe I shall move on to the practical walkthrough. Yeah, because I'm sure you guys are quite acquainted with a lot of these things. So I'm going to the practical walkthrough. Yeah, where's my question? Yeah. So we're here. Oh, sorry, my mouse. No, I'm not trying to share. Yeah. So yeah, this is our practical walkthrough, and what we're trying to do today is we're trying to build a model that is able to classify, that's able to guess how a person is feeling based on what they've typed. From what I've said, you obviously know that the field is NLP because it involves understanding human language. And the problem is classification because we are predicting emotions which are like classes. So it's a classification problem in NLP, you know. And we're going to do something very interesting. As we all know, the LLMs have taken over, and our approach for building the model today shall reflect current technological trends. All right, but before I go deep into that, let me start from the very beginning. So actually, our data set was gotten from Kaggle. We use the Kaggle data sets. Yeah, and it's called the emotion data set for NLP. So that's where in case you want to replicate this in your spare time, you could just simply go here and then you download the data set. Click on download and you download it. I already done that, so I'm gonna go download it again. So just click here, download your data set. Sorry, this is wrong screen. How do I think I'm sharing the wrong screen. Can you guys still see my screen? Sorry. All right, it's just on my end that it looks weird. All right, yeah. So what was I saying? Yeah, so you download the data set and you want your data sets to be you are going to use Google Colab because once you are going to build it, we are going to train a deep learning model, So we need GPUs to hasten that process. So you are going to use Google Collaboration unless the laptop has inbuilt GPU. You can still use Kaggle as well. I mean, it's fine. But I love Google Collaboration, so I'll use Google Collaboration. But Kaggle is also a very good option so yeah, you could use Kaggle as well. Yeah, so to upload your data set, I believe you come here and then go to wherever your data set is and you just choose click open and then it uploads. I've already uploaded mine so once you click open, you would see them pop up and it's show here showing that they're being uploaded, yeah. And if you notice that the data has like three parts, our tests, our training and validation sets. So for those who might not know, your training set is what you use to train your model on to build like a basic competence on whatever task you are trying to solve. A validation test is what you use to tune your hyperparameters, you know, and then your test set is what you use to evaluate your final performance. It's on basically it should be data that your model has not seen in the test or training in the training or validation set. If not, there'll be some data leakage, which means that basically your model will perform well on that test set, but probably not perform well in the real world because this data you are testing it on, it has seen it before. So it's not so whatever performance you get is not reflective of how your model will perform when you see data that I've not seen before, essentially. So that's basically what those are. So in this first cell, we're basically importing our libraries, and the libraries we're using data sets. Yeah, I told you I'm not using Jupyter set just because we are going to make use of a GPU to actually fine-tune our model. On Jupyter Notebook, you're going to use your computer's resources. And if your computer does not have a GPU, you're going to sleep there to fine-tune this model. Why we need GPU is because we're going to fine-tune a deep neural network. We're going to fine-tune one, and that's computational intensive. So you need a GPU. Unless your laptop has one, then you can run it on your VS Code or your Jupyter Notebook. But I don't have one, and for those who don't have one, you can use Google Collaborate or Kaggle, you know. So these are the libraries we're using, and this data sets library, it's from Hugging Face, and basically used to put your data in a stable form for these two libraries. These libraries are important because we are going to use them to fine-tune our model. So for those who might not understand what fine-tuning means, let me just explain that. So for anyone who has been paying attention to the rise to large language models and stuff, you know that large language models are basically like very big neural networks that are built specifically for like natural language understanding, you know. You understand natural language. So, but then when you want to use these models for specific tasks that involve understanding natural language, so in more concrete terms, you want them to be able to talk conversationally. You can fine tune them on a task called question answering. You want them to get better at, for example, understanding human emotions. You fine tune them on data sets that has human texts and then their emotions alongside them. So these are examples of downstream tasks that you might want to fine tune, you know, your models on. Yeah. So that's to clarify that term, and so emoji, we're going to use the clean emojis, evaluate performance. This TF Keras library is a library that's like we sort of need to run, we need to have to run these two. But I think there are other alternatives as well, like accelerate, but I chose to use this. And from transformer library, you're able to get tokenizers, you're able to get you're able to get like NLP you're able to get large language models or encoder models, that you can leverage for natural language processing tasks like we're doing today. We are going to use regex to clean our data. We're going to use Gradle to deploy our model. Because I mean, what's the point of having a model that only lives on your on your Jupyter notebook or your Google Collaboratory? It has to deploy, So I'm going to use Gradle to deploy, and then Seaborn and Matplotlib to just do some EDA, and obtain some hyperparameter tuning. But because of time, I'll probably not do that. So yeah, I've run that sub previously. I don't run it again. So let me just open the data set so you can see exactly like what is inside to see the format of data that's inside. Yeah. So in these data sets, you can basically see that we have like lots of rows. Each row is basically like you have a sentence and then you have an emotion appended to it. Yeah. We all know that when dealing with like our models, we have like our features separately and then our target variable separately. In this case, the features are going to be sentences, and our target variables are going to be the emotions, essentially. So as part of our data preparation process, we are going to have to separate the sentence and the emotions and pass them. We're going to have to separate them essentially, which is this pipeline is going to like put us through. So you'll be able to see the first line of which proposing pipeline, we have a checkpoint called bear based on case. So this bear based on case is basically an encoder model. So what it is that it's a model that has been fine-tuned, that has been not fine-tuned, that has been pre-trained from scratch to understand human language. You know, LLMs are LLMs are able to understand and generate. They comprise of both encoder and decoders. The encoder understands, the decoder generates. We're going to fine-tune a decoder model for, yeah, in the hopes that it can be able to tell people's emotions from the sentences. So whatever model which we have now, it cannot generate, it can only understand natural language, but not generate natural language, Yeah. And there are like several different encoders, but I took this one because like it's small enough that it won't take forever, but also good enough that the performance will actually be quite decent, you know. Yeah. So, oh yes, I typed the code myself. Yeah, it took a while, but typed it myself. Yeah. So, are there any questions thus far? As I've been talking for a very long time. Are there any questions that anyone has? Let me check the chats. Does anyone have any questions? Anyone have any questions? Um, I see a new message. Yeah, I think that would probably be sending the files could be done like after the class, I guess. It could be done outside the class. So you guys sending the files. Yeah. It could be done outside after the class, I guess. So you guys can, experiment yourself and stuff. So for now, just follow and just try to get the basic idea. But always share it inside the class. All right. So these data sets are in TXT files. We have to open them and read them, and that's what this line does. We open these files and we read their contents line by line. That's what goes on there, And then from each row, because you notice that after like for every single row, the emotion comes after a semicolon. You then split each row as that semicolon, extracting the sentence and extracting the emotions. And you can see here that with this line of code, the first part, these sentences are put in reviews and emotions. The second part are put in emotions, anger, joy, whatever, are put in emotions, Yeah. And then we append those to we straight through every round, we append those to a list. Yeah, and then we end go on to create a data frame that contains our pictures and then the categories or labels, essentially. And these labels are these label names are basically words, so we have to encode them, because computers don't understand words in the not in the like innately, they understand numbers. So you have to encode them. We have to encode them, put them as categories, which is basically like discrete numbers, whole numbers, 0, 1, 2, depending on how many categories that you have, essentially. So that's pretty much what happens. Yeah, we create a mapping from our label to our category. Essentially, we want to be able to know what each category represents after we encode them. That's why I created that. And in this part of the processing pipeline, we remove emojis and we replace them with an empty string. Replace them with an empty string. We apply this function to only the text column because that's where our sentences are, and then we remove special characters. So we use regex to remove every character that's not an alphabet or a number. We remove them and replace them with an empty string as well. We apply this function on that column again, And then here we convert our data frame to a um data sets because that's how the libraries are going to use to fine-tune this encoder model. That's the format they expect to receive data. So that's why we do that as well. And then here we tokenize. So remember, we've encoded the emotions, but remember, these sentences are also words. Computers don't understand words innately. We have to tokenize them centrally. So a token is basically like a number that represents like a word or a subword, roughly, So that's what tokenizer is. So you have a function for creating tokens, you know, for creating tokens. And one important thing to note is that this check when you are creating a tokenizer, each model has its unique tokenizer. So if you notice, we pass the name of the model we are going to use. But based on case, we passed it into the auto tokenizer so that the tokenizer that is used is the tokenizer for that model. Because different models use different tokenizers. So that's pretty much the gist of all of that. And yeah, basically ingest our data and then train it by calling the preprocessed data sets, our train, our relation, and our tests. And all these pre-treatment just tell us what is going on. We remove the emojis, okay. We remove the none of America, we converted the data set to the appropriate form. We've tokenized our sentences. So you can just see what's going on for all of them. And here you can see the label to ID map. You can see the labels rather. We have like 6 emotions: anger, fear, joy, love, sadness, surprise. You can see all of them here, you know. And then it does that for the train, the test, and the evaluation. That's why you can see all this stuff written like 3 times, you know. So the next thing is to perform some EDA. And this is very important because when you're dealing with classification tasks, yeah, classification tasks, there's something that happens really. And what happens is that if certain classes are a lot more than other classes, your model would more often than not predict the more numerous classes. And a bit the reason is a bit complicated to understand, so it's a bit complicated to explain, but I'll try my best to like explain it simply. So we all know that like these models are built to optimize certain metrics. For example, accuracy or whatever. So you all know that your accuracy is basically like or true positive over true positive plus false this thing. When a certain like sample is way more numerous than other ones, like obviously your model will just assume that every single to maximize your accuracy value, it just predicts that more numerous class more often, but that's because of the nature of your training data sets. But then when it faces real world data, and that's not the case, your model is going to fail. It's going to fail. So as a result, it's something that we do to address this phenomenon, which is this phenomenon is called class imbalance. And to address it, something we're going to do later on to address it. And some is that we're going to give every class weights, I want to give every class weights to try to get our model to not focus solely on the more numerous ones. That's the gist of it, anyways. And from our plots, you can see what is going on. Like this category is like way more than these two are way more than the other ones. I don't want to ask 2 times or 3 times bigger than the other ones. And that's quite problematic. And that's the same across our validation set and our test sets, the same thing. Right. So if you recall, we have like I created a mapping for our emotions for our encoded values to the emotion. So we can tell what all these values mean. So we can say that 0 is anger, 1 is fear, 2 is joy, 3 is love, 4 is sadness, 5 is surprise. So you can actually know what these numbers mean. So I printed that out here so you can see. Yeah. So now addressing the class imbalance thing, this is what we create our weights. And I put some comments here to try to explain it. So we use I'm not well familiar with scikit-learn library because in traditional ML, most of our stuff that we use to build our models are from scikit-learn library. And even when like we want to like split our data and even perform like things like grid search, yeah. So we use scikit-learn library here again, and we use it to compute the class weights. And you notice, and basically the gist is that the classes with smaller samples are going to have bigger weights. Try to counteract the models likely to focus more on the larger classes. With these bigger weights, the model won't, with these bigger weights to the smaller classes, the model will not focus more on on the more dominant classes. So you notice that all the classes that are less numerous have like bigger weights, yeah. So you can see that the most numerous class, which is joy, actually has the smallest weights. The least numerous, which is surprise, actually has the biggest weights. And that's basically how we are going to address the class imbalance thing. There are other methods like smooth as well that people use, but I chose to use this one just out of fondness of it and out of fondness of it. So yeah, I chose to use this as well. I chose to use this one. That's why I chose to use this one. And now, when we create these weights, what do we do with these weights? we sort of, how do I put it? So deep, because our encoder model is a deep neural network. Deep neural networks optimize the loss function. Well, if you want to change the behavior of a neural network, you have to, whatever you want to change has to be built into that loss function. You tell it how you want it to behave through the loss function. And by passing these weights into this loss function, you're telling, okay, this is how I want to compute my loss. When you're computing loss, I want these smaller, these less frequent classes to be given preferential treatment to sort of counteract the preferential treatment that the model would give the more numerous classes. So that's the gist of what we're doing here, you know. This is what we're doing here, really. And yeah, okay, here I created a dictionary to just do a mapping for the emotions to the weight value of weight for us to see easily. So that's what I did there. All right. So here is the part where we fine tune our model. Here we fine tune our model, the parts that you've all probably been waiting for, you know. Yeah, so if you recall earlier, we imported this earlier from the Transformers library. So auto model for sequence classification, you pass the name of your model you want to use into from pretrained. You pass it and also the number of labels that the number of labels that your model is going to predict. There are six emotions, so you are going to pass in six. Non-labels is equal to six. I initialized this somewhere previously, so I just passed that in here to represent that. And this is the metric we want to use to evaluate our performance. We're going to use accuracy to evaluate our performance. And to actually do the computation, we create this function. And what this function does is that it takes the predictions of your model. Yeah. It takes the predictions of your model. It then extracts the probabilities the model gives to every single, like all the classes and then the labels of the classes. Obviously, the prediction is going to be, when dealing with classification problems, ML models or deep learning models, they predict probabilities for every single class. And then the one that is selected is the one that has the highest probability. And that's what we do here. We MP to argmax to pick the class that has the highest probability. So that's how we know the one that your model has chosen, the one with the highest probability. Right. And then in here, we then compare what the model has chosen to the actual label. And that's how we compute the accuracy like here using this using evaluator, using evaluator essentially. This is how we compute our accuracy. It's a bit different from how we have done it using scikit-learn. A bit different, but not so different actually, but a bit different. Yeah, so and this trainer, I believe I highlighted this trainer class earlier as one of the two classes libraries are going to use to fine-tune our encoder model. So I'm going to use this and then this. This is what actually does the fine-tuning. But then training arguments is what helps us to tune our hyperparameters, you know, essentially. Yeah, so now the thing is, we have created weights for our classes to counteract class imbalance. We've created a new loss function. Okay. So what do we do with this? What we do with this is we we sort of, how do I put it? We make these things like attributes of this trainer class. So if you notice, actually, what we're doing here is that we're inheriting from this trainer class. We're creating a weighted trainer, which is a trainer that's going to, we're building to address class imbalance and it's inheriting from this trainer class, you know. And we inherit from this trainer class. And the major different thing that we do is we give it an attribute called loss function, which is loss function that we have created. And that is how we are going to address the class imbalance thing, you know. And then in it as well, we define a function for computing our loss, you know. Yeah, and these are these mechanisms through which we are able to address um class imbalance. We then create a function to compute our loss. Yeah, essentially. So and this function obviously takes the input obviously and the model because that is what you are going to use to make your predict your outputs and then from the outputs, we get the logic, which are basically probabilities. The probabilities are assigned to each of the classes. And then we use these logics and labels to then calculate our loss really. So that's pretty much what goes on here. As we should all pretty much know, like the loss function is gotten by comparing the predictions to the actual values. So that's similar concept here. Exactly. So yeah. And trying to scroll up, my mouse is name, yeah. And this part of choosing your hyperparameter. So here we just specify what we want our model to be saved, what evaluation strategy we want to use. We want to evaluate the epochs. Well, if you want, like where you want to log your fine-tuning process, how often you want to log. That's what logging steps does. If you want to push your model to Hugging Face, and the batch size. So the batch size is, as we all know, it's very important in building our models, ingredient descent, so when you have more compute, you can use bigger batch sizes, although like obvious there are catches with using large batch sizes that we're not going to get into, but when you have more compute, you can use more batch sizes, but then there are some cons of using too big a batch size, but and when you have little compute, you use smaller batch sizes. So because I'm trying to maximize our compute, if the batch size of just needs on both our training set and our evaluation set, it's usually the minimum that is used. I've not seen anything less than 8 be used. Batch sizes are actually usually in factors of multiples of 8, so 8, 16, 24, stuff like that. Usually, for whatever reason, that is, So, and then we run this cell as well. So this is how you would actually fine tune normally without using our weighted trainer. Without using our weighted trainer, you just call the trainer class and you just put in all these parameters, your model, these training arguments here, and then your training set and your validation set, and then how you want to compute your metrics. But we want to use, I'm going to use our weighted trainer, not this regular trainer, and that's what we did here. We use our weighted trainer. So I rewrote these cells. I'm not sure why. Yeah, that was a mistake. Yeah. And so here is where we actually use our weighted trainer to fine-tune our encoder model. Trainer.train, and then your fine-tuning process begins, you know. And I also want us to print the results to see the results. So this took like an hour to run. Like I ran this like an hour before the class because I knew that I didn't want us to wait for it to finish, essentially, So and you can see my epochs, I think I chose three. Okay, no, I left. I didn't leave it. I didn't put anything. Actually, the default value of epochs is three. So yeah, the default value is three. But I didn't put three. The default value is three. So you did three epochs. And we have three epochs, and we can see how the accuracy improves over time. With the more epochs you do. So the more epochs you do, the better your model can get. But like obviously, if you don't have a lot of time to waste, you can't do so many epochs. You can't do so many epochs at once. So I did just three because of time constraints. It took like an hour for these scripts to run, a whole hour. This batch is in a GPU. So for guys that are asking why don't you use Jupyter Notebook? Despite having a GPU, it took me 1 hour to run this code. So you with your Jupyter Notebook, I don't know how long it's going to take you, but I think you probably sleep there unless your system has a GPU itself. Yeah. So with this line of code, I just save the model and tokenizer. And you will notice that you see this folder is called save model and save tokenizer. Yeah. The whatever you put here is what is going to be the file name of where your model and tokenizer are stored. So that's where they are stored. And this is the juicy part where we actually deploy our model. So we use Gradio to deploy our model, and basically, obviously you have to build the backend. And on the back end, what are we doing? We're making predictions. We're making predictions on inputs that is being passed into the app's front end. And so we write our predict function essentially. So the inputs are being tokenized. Data is the sentence it's being tokenized. And then we want these inputs to be what's what I want to use. Let me use the word processed. Let me just use the word processed. on our GPU. I mean, you don't have to specify actually. If you don't specify, this is whatever compute is available. But like when you specify CUDA, it means that if you don't have a CPU, then nothing happens. It's all run because you can't find a CPU. So I specified CUDA because I wanted it to use the GPU specifically, you know, and to not run if my GPU was not available, So that was that. Here, yeah, so that extracts my key and values from inputs or items. And those and we create like a dictionary. And then here we basically say, okay, stop calculating gradients. So I'm saying don't do gradient descent, just make predictions. Stop calculating gradient, just make predictions. And so we pass the input into our model and we get outputs. And then we extract the probabilities assigned to each class, you know. And then the one the highest probability class that our model has chosen, obviously, and that's the prediction, and then we return that prediction. So that's the backend and this is the front end essentially, you know. So build the interface, function, the backend, and we want and then inputs and the outputs and the title. So the title is here, and we want it to want to receive an output text, and the yeah, and then we'll relaunch and then we'll run. This is still running because I haven't like stopped the app since it got deployed. And so you can just test now. And I did a test earlier, so lovely pizza, that was the comments. And then we predicted love, obviously, out of anger, surprised, sadness, joy, love. We picked love, which I think is quite close. So you could try another one, try another prediction. Um, yeah, so and then you can see, like, it picked anger anyways, and all I guess, given the options that we have, I guess it's best suited emotion as well, for this particular thing. So the key thing, this does not have to like run in Colab. If you click on this link, you'll be able to like run the interface like in a separate tab, and it's taking forever to load. Yeah, okay. Yeah. So if you run the interface in a separate tab, you'll be able to access your app and stuff. So, and then you could test it as well. So I so yeah, so you guys should drop in the chat. So what's text? Oh, he said anger. Now that is interesting. And this is how we know that our model, you know, has not reached 100% accuracy. So once in a while they still will misbehave. That's why the background is quite high. It still misbehave a few times. So you guys drop in the chat things you want me to input into our web app to see what emotion to give them. So whatever you want, whatever text you want us to input, just type it in the chat and then I'll input it in our web app to see what our model predicts as the emotion. So guys, I don't is there anything you want you like to check. You would like it to check the sentiment or type in the chat, please. That's not bad. So and no one is typing in the charts. No one wants to test anything. Ah, all right. Someone said Tinubu is a handsome one. All right. Thank God it's Friday. Let's see. Yeah. Thank God it's Friday. Joy. Yeah. So let's see the other ones. Well, where are the chats? I'm struggling to see the chats. Why can't I see the chats anymore? Okay, yeah. So let's see. To air is human. Let's see. Let's see. I always lose that. I'm not typing that one. You can type down on your own when you deploy your model, but I'm not typing that here. All right. So air is human fear. That's a very interesting choice by our model. Yeah. So change is inevitable. Let's see. Yeah. So I think I have checked that already. I meant to copy. What's it called? I meant to copy. Where was it? Uh, yeah, this one I meant to copy. Let's see. Let's see. So change inevitable. Joy. Ah, that's interesting. Um, that's interesting. I mean, I'm one of the best player in the world. Okay. Basta fall in the house, I imagine. All right. Um, let's see. Yes, you can really deploy any machine learning model. You can also use Flask as well. I mean, Flask is another option that you can use. But I didn't use Flask because, yeah, first of all, Flask on Google Colab was no, like when I tried it, was a bit, was stressing me out. It was stressing me out. I had some errors that I couldn't really debug, so I decided to use Gradio just to save time because of text deadlines, So I used Gradio to deploy the model. It's a lot simpler than using Flask, but I think Flask gives you a little bit more control of certain things, particularly like on the backend stuff, on how you like respond to requests. So I hope that answers your question. Yeah. So let me see this. What here? So yeah, so submit fear. Ah, well, let's see if I put an exclamation mark with the sentiment change much. It's still fear. All right. What if I put a question mark? You expect that to be surprise. It's still fear. That's interesting. Very interesting. I wonder what will happen when we fine tune over like 10 or 15 or 20 epochs and how much our performance will differ. That would be a very interesting experiment to run actually. You know. I think there's one more chart I saw that I missed that looked very interesting. Let's see. Um let me even add this. Let me even add this and put to the model. Let's see what it would say. Uh, let's see. That says joy. Okay. Well, I mean, six emotions is a very narrow range, and there's so many emotions that human beings can express. So I guess that's some way we can, that's we can cut our model a bit of slack here because there's so many emotions that we can express. Well, joy is a very interesting choice here, very interesting choice. Okay. Yeah. So let me try. Okay. Like leading you where you're from Africa. Interesting, interesting. All right, let's see. Let's see how that performs. Submits, and what happens? Joy? That is definitely no joy. I guess that's definitely no joy. Hello. Why would you misunderstand so much? The peculiar nature of how we write or how like this sentence is written. I mean, when you say leading you, it's a very Nigerian way of writing things. So I guess that could be a reason why it's predicting joy because this is also not a joyous remark. So I wonder how it would be if we like fine-tune our model on like more Nigerian like phrase. I wonder how it will read this in that case. So that would also be very so this just shows that like I mean yeah, so we don't do it to direct. Let's see. This will really fall under I mean anger, surprise, joy, sadness. It's not doesn't really fall under any of those emotions, if I'm being honest. It says joy. All right. Um let's see. Victor Osimhen's aggressive strike. He was filled with laughter when he saw the team of a train moving train. All right. Let's see. Fear. Now, I think that's a bit weird. Someone is filled with laughter and you're predicting fear. Nah, that's not correct. That's not good enough at all. Now let's do like two more, I guess, because of time. I'll pick this one. I like this one. The next one I'll just randomly select one. I wonder what to say here because you know how when we say aggressive in football, it's sort of like depending on the context, it could mean a good or a bad thing. And this is like a good thing. So let's see what it say. It says anger and you know. So this is another thing. Language is very nuanced and in certain like area walks of life, words that we use in every day sort of mean different stuff. I need an example of that. In football, when you say this is usually a good thing. But like in this case, our mother does not really understand football context, so it then to this anger, so these are the things you have to pay attention to whenever you want to fine-tune a model for a particular use case. Who's going to use this model? Who? And if this model was meant to be for football discourse, like obviously we tried to get data that was more aligned with that, you know, to get better performance and stuff like that. So um let's see. Well, I mean, so because Peter, this model is an encoder model, it can't generate output. Its job is just basically to understand language, it can't respond to you in the actual sense, so this model can't. But if you're to fine-tune a large language model, like an encoder a model that's an encoder and a decoder, it could probably admit that it doesn't know the answer to a question because it can generate, but this is just an encoder model. It can only understand when it can't generate answers. So I hope that answers your question, Peter. Yeah. Yeah, actually, you have a very good point. There are two work on sarcasm. Yeah, I probably won't. Probably have to create a data set for sarcasm, you know, for it to pick that up actually, so yeah. All right. So, does anyone have any other questions? Because I guess it's the end of the class, and we'll try to get the code and other material across to you so you can run it yourself and see how things work. Hopefully, you can watch the recording afterwards to implement the code. Yeah, and to just experiment. So, any questions, guys? Any questions? Any questions? Any questions? Yeah, this model has already an encoder. Yes. Okay, so epoch. How would I describe what an epoch is? Let's say, okay, think about how we call a revolution around the sun a year. Okay, an epoch is basically a, let me use the phrase a round of training. So let's after like one round of training, we say an epoch has happened really. As for what the hyperparameter is, hyperparameters, and this is going to sound very funny, but they are parameters of parameters. I know that sounds very convoluted and funny, but let me put it this way. Your model would be trained in a different way based on certain arguments you pass into like the model when you want to train. And these arguments that affect how training happens are called hyperparameters. So it could be things like your learning rates, for example, that's a hyperparameter. Things like your batch size, that's a hyperparameter. They influence how your model learns. So yeah, I think that's the best way to put it. Hyperparameters are parameters that influence how your model learns. You know, as for loss function, a loss function is just like I will describe it as as a particular expression that like sort of evaluates your model performance. So how does it evaluate performance? It basically compares your model's results to the real results. So it tells you how well your model is performing actually. So that's what a loss function is. Logic is basically like the probabilities that your model gives to all the classes. That's what legit is, you know. And weights, in simple terms, basically like the, let's call it the importance that your model gives to certain features in your data set. So I hope I'll be able to explain those terms in a way that you can understand praise. So yeah, thank you, Ezekiel. Yeah, you can improve the model by adding more data. Yes, Peter, you can improve by adding more data. You can improve it by tuning your hyperparameters, as I mentioned earlier. But the honest truth is that the, the way that give the biggest ROI is improving the quality of data. So you get more data, but also the high quality data. Hyperparameter tuning can only get you so far. If your data set is not that good, your model, the feeling of your model's performance is capped. Despite all the hyperparameter tuning or virtual engineering that you might do. But when your data set is large and rich, your baseline performance is high, and when you tune your hyperparameters, you can get even way better performance. So that's how it is on Peter. Yeah. For you to consider it good enough, well, I'll say it depends on the use case. So let me say it like this. Let's say you build a model that you want to diagnose people, that wants to diagnose illnesses to people. Health is a very delicate thing. If your model doesn't make a right prediction, like it will kill somebody. So obviously, in that case, you want your model to, if possible, be like 98, 99% good. You know, 100% performance is not really possible. And when you have 100% performance on your test sets, my friend, I'm trying to tell you that you are probably overfit. Your model is overfit, and your test set was probably in the training set. That's why you can get 100%, but it depends on your use case. So for something like health, you would want to get as high as possible, like 97 and above. But for less critical things, let's say 90% could be good enough. In some cases, 85, but so it depends on the use case and how big the margin of error is. Yeah, exactly. Epoch is number of training cycles, praise the number of training cycles. That's what it is. Yeah. Yeah, exactly. We're trying to train our model to be able to understand the emotion based on a person's text. So it's be able to read a text and be like, okay, this person is angry, this person is sad, this person is joyous, person is in love, this person is happy or whatever, but they have just six classes, so it has to like predict some of those six classes. And we all know that like emotions are wide ranging, so those six classes don't exhaust all kinds of human emotions, so that could explain cases whereby the emotions it predicts are not quite right. Because in the out of the Monjam now data sets, the text you put is not really like stable for any of them, so it gives some very weird suggestions. So that's what we're trying to train our model to do. Yeah. The name of the predictor using this model. I'm not sure what you mean by the name of the predictor using this model. I'm not quite sure what you mean by that. Not quite sure. Quite sure. Well, yeah, so in the traditional sense, with feature engineering, in traditional sense, in this sense, we didn't really do much feature engineering. We just cleaned our data and then did some EDA to know the spread. But in traditional ML sense, where you have like proper like tabular data and features, you could multiply certain features by each other, you could add them, you could subtract them, you could divide them, depends. It totally depends. And that's when ML will say that domain knowledge is very important. So if you have domain knowledge, you'll be able to tell how to engineer your features better, but you can also just be able to through just experimenting and pure luck as well. So but that's why a lot of the time data scientists try to like read about whatever tasks they want to get their model to perform so they can know how to feature engineer their data better, whether they are multiplying certain features together or adding them or dividing them or subtracting them. So stuff like that. So stuff like that. Yeah, Gradle can be used for all. You can use Gradle, you can use Flask. Yeah. So, guys, thank you very much for your time. I hope you were able to learn a few things and enjoy yourselves. And this marks the end of our class. Thank you.
Wow, wow, wow. Great delivery. Thank you so much, Ewezu. If you enjoyed the session, let me see your yes in the chat. Let me see your favorite emojis in the chat. This has been an awesome 1 hour, close to 1 hour, 30 minutes. This is what I call great delivery. Like I told you when we started the class, like this is Airways is just coming back to take us again, just like it did last year. I can see a lot of emojis in the chat. I can see a lot of yes in the chat. Yes, it's been an awesome session. So, anyways, I don't know if you want to share your LinkedIn profile with our audience. They would like to connect with you, so you can just drop your LinkedIn profile in the chat before we end the session. Thank you so much, Ewezu, for taking us this afternoon. So, just few things before we wrap up today's class. And yeah, we've done a lot. He has done a lot, taking many questions. So we're not going to be taking any questions again. So the conversation continues on the Telegram group. If you have any question, you are free to drop them on the Telegram group. Ewezu and everybody is on the Telegram group to support us. And this is the attendance QR code. We've been sharing the link in the chat since the beginning of the class. So if you are here to fill your attendance, quickly scan this QR code to fill your attendance. It's very important that you mark your presence. Remember, I said the journey to the boot camp begins with the prayer classes. The only way we can track your uh, the only way we can track your participation is by filling this attendance form. Yes, so it's very important that whenever we come into a virtual live session like this, you fill your attendance. And I would also like to hear from you. We want to know how to improve our delivery. Yeah, it is our duty to expose you to all these learnings, but we always also want to improve in our delivery, the coordination of the class and all. Let us hear from you. And one thing is that this feedback form is it's not going to collect your mail address or even your name. So you are going to be filling it as an anonymous. So feel free to let us know what you think about this class and the things that we should improve on. Yeah, we will really, it's going to excite us to see your feedback, and then we can um take learnings, and then we can improve on ourselves. And yeah, so that is actually all for today. It's been an awesome 1 hour, 30 minutes. Thank you so much for joining us. But before we round up, I need to let us know that the learning continues. Yeah, we're running 4 cohorts this year. We've started with the data storytelling and visualization for the data analytics guys. And then this week we just concluded the Python for data science and machine learning. So now we're done with the beginner's track. These 2 courses, data storytelling and visualization and Python for data science and machine learning, are actually for the beginners. People who does not even know anything at all. And that's why we've been sharing you all learning resources. Every learning resources that will help you out to quickly get you on track. So from next week, we are going to be moving to the intermediate track, which is introduction to prompt engineering. So this week now we'll be introduced to artificial intelligence. Next week, we are going to be introduced to artificial intelligence proper. How can you prompt AI to help you achieve a lot of what you want to do in this field? So that's what we're going to be learning all through next week. And next week is going to be a virtual live session all through. Let me repeat that again. Next week is going to be a virtual live session or and what that means is that we are going to be coming into the class every day for the 5 days. We are going to be coming into the class every day for the 5 days from 2 p.m. to 4 p.m. Nigerian time. So make sure that you add this to your calendar. If you've also registered for the introduction to prompt engineering, we are going to be sending you an email before Monday so that you can get the Zoom link to join the call on Monday, 2 to 4 p.m., on Tuesday, 2 to 4 p.m., on Wednesday, 2 to 4 p.m., on Thursday, 2 to 4 p.m., and then on Friday, which is going to be the final virtual live session class for Introduction to Prompt Engineering from 2 to 4 p.m. Yeah, so we have our facilitator who is also going to be taking that learning track. And then in the next 2 weeks, we are going to be wrapping it up with Microsoft Fabric for data analytics. End-to-end data analytics with Microsoft Fabric. It's also going to be a virtual live session all through that week. Yeah, the whole idea is that, okay, you've learned about data analytics, you've learned about data science, you've learned about data engineering. How can you bring all this together in a place? How can you use all this together at the same time? That's what Fabrics will allow you to be able to do. Thank you so much, everyone. It's nice having you here, and I'm also excited to be your host for this afternoon. So this session is recorded, and we're going to be making it available for you as soon as possible. Yeah, this session is recorded, and we're going to be making it available for you as soon as possible. All you need to do is just to keep tab on the DSN YouTube channel. That's where we upload all session recordings. So if you are not familiar with the DSN YouTube channel, just type on Google DSN YouTube channel. I mean, just type DSN Data Science Nigeria, and then on YouTube, you are going to see all our videos there. And like I said, the conversation continues on the Telegram group. So if you are not on the Telegram group, make sure that you join the Telegram group, and then you can ask any question that you have, and I will be there to provide answers. Thank you so much, everyone. Do enjoy the rest of your day. I mean, enjoy the rest of your evening, and do have a great week ahead. Bye, everyone. See you next week, Monday.